So NADPH is primarily produced by the pentose phosphate pathway in the cytosol. And so if you have genetic SNPs related to those genes, then you may not have adequate NADPH production. Secondary ways that NADPH are produced are through the Krebs cycle, but it's not in the mitochondria. It's citrate and malic acid, but it's in the cytosol, not the mitochondria. And so if you have SNPs in those genes, then you're gonna have decreased NADPH. And then the folate pathway, the part that produces NADPH is the MTHFD1 and 2 genes. And so if you have a genetic SNP there, or even if you have the famous MTHFR genetic SNP, you may have a decrease in production of NADPH. As I said before, the pentose phosphate pathway is the primary way that the body produces NADPH, and these others are just kind of like helpers. So this is a pentose phosphate pathway, and here we have glucose 6-phosphate converting to the 6-phosphogluconate, and the 6-phosphoglutamate converting to the ribulose 5-phosphate, and both of those produce NADPH. And so this is a pathway that not uncommonly has genetic SNPs, and so that could be a component, a reason why some people are more prone to heavy menstrual bleeding. So here's the NADPH oxidase. So this whole thing is going to be related to NADPH. So here is that pentose phosphate pathway again, where we get NADPH production. And it's kind of neat because they also include the Krebs cycle. And we see that outside of the mitochondria in the cytosol, we have production of NADPH related to the Krebs cycle, but not the same. Sorry, my cat is going crazy. She unplugged my computer. And the same thing with the isocitrate here. And then this is the folate cycle. In both the MTHFD2 and the MTHFD1 produce the NADPH. And I wanted to show you this one because I wanted to show you how it's related to the methylation cycle. And also, here's the MTHFR. And so you're gonna have sluggishness in MTHFR also if you have genetic SNPs in the MTHFD also. So again, we're talking about the arachidonic acid being released from the cell membrane when we have a decrease in progesterone at the initiation of menses. And that arachidonic acid is broken down by the COX gene, and the prostaglandin H2 is released, and that can either break down into the prostaglandin F2 alpha, which is vasoconstrictory, or prostaglandin E2, which is vasodilatory. Prostaglandin E2 can then break down into F2A if there is the NADPH involved. If there's not, then that process is just going to be sluggish, and so you're not going to get adequate vasoconstriction.